Hello and welcome to the Extended Greg YouTube channel. And I'm Greg, and on today's show we're going to be taking a look at, well, have you ever wondered where programs come from? Well, when a developer loves his source code very much, he wants to compile it and make an executable. That way he can have little child processes running around the operating system. Yeah. So today we're going to be compiling FFmpeg from source code, so let's get right into it. Okay, so a little bit of a new setup here. So I actually have a computer that we can remote into in order to be able to actually do some research. So the idea behind this is that we're going to be actually going through all of the steps from research to actual final execution of the FFmpeg compiled script itself. And from there, we're going to go through all of the steps. We're going to look at options and actually go through it as if you were going to research this and compile it yourself. As far as, there's no real magic here. We're going to have to install a few applications, but the rest of it is pretty much automated. It's going to be pretty much a makefile. We can select some custom options if we chose to, but we're going to go through all of that. So the first thing that we're going to do is we're going to actually find the FFmpeg compilation guide. And a lot of major projects will have something of this sort that will guide you through the basics of actually compiling their software, because anytime you have a different architecture or something else like that, you'll need to compile a version that will be capable of running on whatever operating system that you have, and also the architecture. Examples of architectures are like 64-bit, x86, and then ARM. And then there's different variations along based on what the options are for the individual kernel that's running on each ARM processor. So there's a lot of variation in play. So let's just take a look. So first thing that we're going to do, let's just look for the FFmpeg compilation guide. And we're not doing this on Windows. We are going to do this on Raspberry Pi. But we're going to use this as just kind of our reference machine, so that way we can look at what we would actually have to do, and then we'll switch back and forth between this and the Raspberry Pi OS instance to be able to do it. On the bottom left-hand corner of the screen, you'll notice which machine we have at any given time, but I think since one's Windows, one's Linux, I think it should be pretty obvious. So let's go ahead and click into the compilation guide we have here. There's also one for Ubuntu. And in fact, that actually might be the best one to go with, just because we're running a Debian distribution, which is Alpine Linux. Now, some of the things may not, go across verbatim, but it is something where, generally speaking, it's actually pretty easy to be able to find the equivalent. And especially with apt, everything else like that, it makes it a lot easier to be able to do so. So let's just kind of go through what's here first. So first thing is we have sudo apt get update, and I did finally get a monitor so I could see what I'm actually doing in real time for the mouse, for the sake of the mouse. So it's telling us to get the dependencies, which there's a decent list of dependencies, so we'll probably also log in and just copy this and paste it. But for the purposes of what we're looking at here, I think this is fine. So it's asking us to install a number of other dependencies. Notice that a lot of these have the -dev at the end. So they're traditional flags that you would need for runtime, but they're the development version, which means they include the source code to be able to be referenced and compiled in. Then we have the compilation and installation. So we do the /configure, which will pretty much allow us to be able to choose all of the options that we want in order to actually do that. And then we will make it. So we'll do make -j4 to run 4 threads simultaneously, etc. And pretty much that will actually compile the script. Now, it gives us some it seems like it's very long, but if we can't find it, we can actually compile any of the packages that we need from source if there's none offered. So for us, we should have most of these. We may have to compile a few from source, but we'll go through it step by step, and by the end of it, we'll have a working copy of FFmpeg. You know, there shouldn't be any coding required or anything else like that. We just have to be able to choose our options, so that way we know exactly what we want. And here's an example of the /configure. So it actually gives us all of the things that we would potentially need. So we could build a snapshot version in order to run the absolute latest if there's some kind of feature or break fix that we actually want to try. But we could see what they have it built with here, and this is actually a pretty standard distribution that you would see on most OSs. But after we're finished with make, we would do make install, which would make the final executables that we'd run and actually put them in their place, wherever we specify. So, you know, it's something where it makes it very easy to kind of follow along, which is why I think this is a very good starting project. And then from there, you know, you actually can do something very useful with it. You know, like transcoding video, like broadcasting your camera, like we did in a previous stream for the live webcam stream, and pretty much anything else you can think of that will fit within the inputs and outputs of the program. You know, it will pretty much just do it, and you know, try its best. So it's definitely a very powerful program. So let's switch over to that right now. All right, so this is the Raspberry Pi OS, and we're gonna just pull up the same exact thing that we just pulled up so we can just copy and paste. So the way that we're actually gonna do this is we're gonna open up a terminal, and it will let us copy in between these. So I'm gonna try and just see if I can make this so we can see both at the same time, which will make copying easier. Magic. Okay, so I'll fix that for everybody who's got OCD. So let's actually just try this verbatim. So we're gonna install all of these dependencies as they're listed. And let's see what it does. And I'll expand this out. You do see that it is in fact running. So right off the bat, we didn't have to do anything to interpret this, but you know, it is something where sometimes, depending on what the features are that you need, you may need to include something that is not widely distributed or widely used. So it will actually come through and say, can't find it. So you'll have to compile that from source. Now, FFmpeg, of course, is available in the package manager as well. But in our particular case, let's say we wanted a special option that wasn't available otherwise. This is a great way to be able to do it. Or if you want to add in a custom feature where you modified the source code yourself and want to try it out, this is a good way to do that as well if you wanted to contribute to their development chain. Excellent. So we have all of our dependencies installed. I don't see that there were any issues associated with the with actually running that. It would have said so at the end. So let's continue on from here. And we're just going to scroll down to the bottom because it's just going to give us some examples so we don't have to type everything. But we're going to make a directory called FFmpeg sources. And we're just going to do this in the home directory. Right, so pwd, it's just our directory here. So we'll do make dir, FFmpeg, and I believe it does have an underscore. We'll just match it exactly. And now we can run this. We're just going to do it one step at a time, just so we're not glazing over everything that's actually happening here. So we're going to change into that directory. Then what we're going to do is we're going to do a wget command. And what the wget command here is actually going to download the latest snapshot from the FFmpeg GitHub site. So, and I can actually even zoom in here so you can see it. but we see that it's wget FFmpeg snapshot. So if it was a release, it would actually have the release number here, but because we're just going to take the current version, which is pretty much a nightly commit of the day's work, we're going to get the absolute latest version of this possible. So let's paste this in, and wget just downloads whatever the URL is. And in this case, it says the -o is to output it to a specific file name. So we'll hit enter. We see it takes a second, but then it's downloaded. So now what do we do with that? So we're going to untar it. Okay, and it's a BZ2 compressed file. So it's a tar file, which is an archive like a zip archive, and BZ2 is the compression that it's using. So we'll paste this over, and we will untar it inside of this folder. And this is why we made a folder, is because there are quite a few files. FFmpeg has been around a really long time, and people have constantly been adding to it, and very rarely are things actually removed from it, just for backwards compatibility, or also if you wanted, maybe not included in all the releases that are compiled out there, but as far as the general source code, that includes everything, because you don't want to delete somebody's work in case you need it in the future or somebody still needs it now. So if we ls this directory, we see that it exported, or it unzipped, untarred everything to an FFmpeg folder. So next we're going to cd into that directory. So this is where it gets kind of interesting. So we need to specify a few things for our /configure file. And one of those is where our bin folder is. So first thing I want to do before we do any of this is I do want to make sure, well, actually in this case, we're going to make sure that our path is not actually going to conflict with the regular installed package of FFmpeg, or it will start to break things. And just for our own sanity, we're just going to avoid installing it to the bin folder, which is where FFmpeg is usually loaded when it's installed from the package manager. So in this case, we're going to put it in the home/bin. That's what it says here. And then add that to the path file. So that way, when it does create it, it's going to be we're just going to be able to call it FFmpeg. So before we do that, we want to make sure that the regular FFmpeg is not installed, otherwise we won't know what we're running. So let's just do apt get remove FFmpeg. And I have to do sudo in front of that. And hopefully this is big enough for it to be able to be read. I actually might want to change that really quick. Oh, I could just zoom. Excellent. Otherwise, this is going to be very tough to read. And I spent all this effort putting in this additional monitor, and I keep using the screen anyway. Excellent. Okay. There we go. So we're just going to make sure that it's not currently installed. So we'll do sudo. So right now it does say it exists. So let's actually do a different command. And I haven't gone over this previously, but it is something that is very useful. So let's say you have a package. If you just do remove, it will leave all of its dependencies in place. If you want to get rid of everything that was installed when you installed that package, you do -- auto remove. And I might have put it on the wrong side of remove. Let's fix that. It's an option of remove, not of apt-get. Okay, I guess that's the only one that was installed as part of that, or it's not recognizing the dependencies associated with it. So, at this point, there may be other things installed. I will say this. I have found that when I've compiled it in the past, if I do run into issues with it running, if I port it to another machine, sometimes it does help to install FFmpeg and remove it once in order to make sure that it's working. But if you compile it on the machine that you're going to run it on and leave all the packages installed, it will definitely run. It will run fine. But that's an FFmpeg specific thing, just so you know. So now that we've done that, let's go back over here. We're going to do our configure. So we're in the directory that currently has our source code, and we're going to run it. So it's going to add the path. The bin file here is the path. It's going to put in what our package config path is going to be. So it's going to put it in a folder called FFmpeg build in our home directory, lib, and then package config. So that will be created as part of this. And I'll expand this a little bit because this is a bit of a long command. And let's run it. Now, this does not do any compiling, but it does a pre-selection process. So what it is doing in effect is it's actually going through and saying, you want this feature, you want this feature, you want this feature. And what it's doing now is it's printing out what you're going to have after the fact. So if we look, it's pretty much doing everything. So we're going to use the GCC compile, the compiler, glibc library. We're on AArch64, which is our system architecture. And we are, because this is a Raspberry Pi 5. It says big endian. So this is pretty much the byte order. So does it want the big end first, or does it want the little end first? And it says big endian, no. And so that means it's little endian. So that's what that means. Runtime CPU detection, yes. Neon, etc., etc., etc. Strip symbols, etc. So pretty much, it's going through. It's telling us exactly what it's going to do, and then it tells us all of the commands that will be available as part of the executable once it is compiled. So there are a lot of them. So examples of very important things. So we see like the programs are FFmpeg, FFplay, and FFprobe. And then down here we have decoders. So we have a lot of available codecs for decoding, a lot of available codecs for encodings. We have hardware accelerators. So we see it has VAPI, VDPOW, a lot of those. And to be completely honest, we're not going to use any of those because those are Intel architectures and I believe also for AMD. But it doesn't include the M2M libraries. But we're just not going to worry about that right now. But if we were going to compile it, it would be a good idea to include hardware encoding if you did want to for the hardware that you're on and turn off the things that you don't actually need. So, but it shouldn't prevent it from compiling. And then parsers, so this is pretty much the wrappers, everything else like that, AAC, etc. Demuxers, again, muxers, we're not going to go through that. Protocols, quite a few of them here. And then a lot of filters. So these are all of the filters available. Bitstream filters, which is what BSFS stands for. And pretty much those are to do minor conversions to syntax changes between certain formats and things. And then in devices and out devices. So, very exciting. So let's actually get compiling. So what we're going to do So these are the options that we're going to choose. We could have pre-selected these as well, but these are the options that we're going to choose. So we're going to do GPL, which is the general public license content. We're going to do the GNUtils, lib, AOM, a number of these. MP3 is in here. Free type is a text. AAC is in here. libopus is a format. libx264, libx265, things like that. And selecting only a few things is actually going to make this compilation time a lot shorter. If we just did make, it would do everything that it listed. Now, granted, we could put all these in before the .configure, and it will show us exactly what things that we are going to get. So we don't have to specify it in front of make, although we are. And actually, I should say that, but they've just formatted it and put it on a new line. But it is supposed to be part of .configure. So let's run it. Let me actually select the whole thing then. So we see everything that's available, and now we're going to actually put it in with the options that we want. So this is not the make command, this is still ./configure. But they put it after and on a new line for each one, which is fine. Makes it difficult to read, but... So now what it's doing is it's going to select those specific options, and we can compare the list between the two. And it says GNUtils is not currently found. So what we could do is, let's try doing apt-get install GNUtils-dev. Because again, it wants the dev, it wants the source code, the .h file is how, and so it can reference it in the source code. Let's see if it exists. Again, I have to run sudo. Too much time on Alpine Linux. So it says it's already the newest version. So it has libgnutils. So it did make the correction as well. Let's see if we can run it again. Otherwise, we can try and exclude that particular enable to see if we can pretty much just skip over it, especially if we don't need the functions that are included with it. So let's see what that gets us if we do that. And I can't hit the up and down arrows or it will change the selection altogether, so I do have to do the actual forward, backwards through the entire line. So it gets a little bit annoying, but I'm recalling the previous commands by hitting the up arrow. So obviously we want to make sure that it's doing it. AOM is the same thing, so let's try that again. Says unable to locate package. So what we're going to do is, instead of using apt-get, we're going to do apt-search. And we'll see all packages that come up with libaom. So it does have libaom-dev. So let's install that instead. Which again is what we need. So now that that's installed, let's try it. And it says it actually in the search, but it's for the AV1 codec. And dev1d is needed. So let's go ahead and troubleshoot that. So we'll do sudo apt, let's just do search right off the bat. All right, and it's libdev1d -dev. And the way that /configure works is it will automatically exit as soon as it gets to the first error. So we can't just get pretty much all of our errors all at once. And let's see what the next error is. Or, no. So this is the libfdk AAC. So we could try and install that, but we may need to compile this one if it's not available. So let's do a search. So sudo apt search libfdk _AAC, and we know we're going to need the -dev. So it doesn't have it. So let's go ahead and compile that. So when we go over here and we scroll up, so it shows us like we could have compiled this here. So right here, it's a dash. So let's try this. Let's just try this first. I put an underscore instead of a dash. So it does in fact have it. So at some point we'll come across something we can't get. And we'll probably have to do NASM. Let's see. Although I think it did say it had it. Anyway, let's try it again. See what our next error is. Opus. So we can search it again, but let's see if this has a quick sheet for it. libopus dev. And this is one of the nice things about using Raspberry Pi OS generally, is it shares a lot of packages in common with Ubuntu. So a lot of the names, everything else like that, are pretty much going to be verbatim. So let's try this again. SVTAV1 encoder. So this one we definitely have to compile. And actually, let's go ahead and do that. As exciting as it is to watch it error out, but let's just satisfy this, and pretty much everything else we can just about remove. But so let's cd back to our sources really quick. And actually, it does have that command in here. So we're going to cd into sources, and then we're going to get the actual thing that we need by git cloning it. And what git clone means is it's going to bring in everything and all the changes that have ever been made to it, so it can get you to the finished file. It's like it's doing it, it's the other way to do it besides downloading a zip file. And then we're going to make that directory and make build pretty much inside of that directory. And this is just creating the directory. And then we'll cd into it, and then we'll go from there. So let's just do up to that point where we cd into that folder. So we're going to see a bunch of things happen all at once. And the reason I can do this is because there's the and symbol, which allows it to chain the commands together. So we'll hit enter. We see it's cloning into the directory. So right now it's going through the changes, everything else like that. So it's bringing it up to the current state of the repository. And it's done. And we see that we're now in that new directory. If we ls, there's nothing there, which is fine. Which should be fine. We're going to find out in a second. Okay, so I see what happens here. So it's doing cmake first. So it's going to put in a number of Unix make files, things like that, and then it's going to pretty much back out one directory, it looks like. Let's find out. So we're just going to run this one part of the command. Right, we see what it's doing. And now when we ls, we see there's a bunch of files that it just created. So it's procedural creation of those particular files based on the options that we selected. Now we're going to build, we're going to do make. And pretty much something that we can also do is we can add option J4, and this will make it do 4 threads at the same time. This is a pretty fast compilation anyway, but we're going to try it because I'm pretty curious how fast it will actually go on the new processor on the Raspberry Pi 5. So here we go, it's off and running. it is speeding through the actual compilation. If it did present any errors, they would show up in red, but right now we see everything is looking green. There will be a lot of occasions where it will present warnings, especially during the compilation of FFmpeg. But warnings do not mean anything has gone wrong. Usually it means that there's something deprecated or something that will be removed that won't work in the future, but is still working now. So just something to keep in mind. But we do see that it's moving through everything. It's building target, so it's building components for each individual aspect of what it's building. And then it's going to build all of those, and just kind of like a tree, it's going to start building down until it gets to one single file at the end, which is the executable or the library. And here's the examples of the warnings that I was talking about. But again, it doesn't mean anything's wrong. In this case, it's just syntax things of that nature, but it doesn't mean that anything went wrong. And we see that it completed successfully. It says that it's linking, build target. So it built the target that we wanted it to. So now that we have that done, we want to do make install. And that's going to install it to the path that we have. And we probably have that in our path variable like 16 times by now. So we see that that was a lot faster because pretty much it was just moving files to their appropriate locations in order to be able to run. So it installed it, and we see the actual locations where it did install it. So we have the lib directory, include directory, etc. So everything is there ready to go. So now when we rerun the previous command, the /configure, it should come up with something with a completely different error. So let's try it. Oh, we have to go to the right directory. Right here, and we see in green right here that we do see the configure file. So that's the one we're actually calling. It's an actual script that lives in that directory. So now it's libvpx. So let's go back through our list here, and we could have just preemptively installed all of these, but where's the fun in that? Let's paste it in. Checking once again, and X264. So we're in the home stretch. We see it working through the list of options that we've selected. So we'll do this one, and we'll also do X265 because I know it's going to ask for that. Just to kind of move things along. Okay, so I'll install those 3 packages. Let's try it again. And there are ways to be able to automate this further, so if you do this all the time and you're going to be installing the same things, you'll either have everything already set to go, or you will actually go through and you'll try and make a script to kind of do it all for you. So in this case, it finally succeeded. So we see everything that would be available to us. Right, so it looks pretty much the same with a few additional options. So the external libraries is definitely different, and a few other things. Perfect. And we see that everything that we actually ran it before, but it didn't have to change, it says is unchanged. So we didn't have to redo that work. So it's very nice where it doesn't it's going to do it as efficiently as possible because it knows generally when you have errors, things like that, you're going to have to keep rerunning it again and again and again. So you don't want to have to wait or have to do unneeded work. So now that we're down here, so we've completed this command. So now we actually want to go and we want to do make. And just for what it's actually doing here is there's a variable called path. So if we just do echo path, we see what's currently here right now. So pretty much we're adding to that again. So I'll paste this in. Now we have make. I'm going to do -J4. And we can actually potentially time this as well. I'm going to open up a new tab over here, and we're going to just search for it. So we're going to do Linux time make. Let's do how to time. Because the reason is so pretty much what it's saying, you know, we're just going to go to Stack Overflow here, and well, it actually answers what it is, but there's usually options based on what you actually want to do with it. But we're just going to do time make, but it's going to tell us how long it's actually taking in order to do it. Let's just do that. So we're going to do it after our path declaration. So pretty much when we specify a path here, we're saying that to this executable, we want to make it so the path variable is set to this because we put it on its own line. If we put export and then path, we can make it so it's permanent. And when we run it, we may need to do that. So we're doing this. We're going to use 4 threads using the J4 actual flag. And then we're ready to go. So we hit enter, time command not found. That was me using the regular apt, which is more graphical, but. So now we're going to try it again. So it's off and running. So now it's actually going through. And we see that it's doing some compiling. So it's taking the .o files, it's compiling them down, and then you'll see a gen come through when it finishes each segment. And it's again going to kind of boil it down so everything kind of comes together and meshes into this single executable. And by the time it's all done, so it's taking what in effect is regular text. So it's code written in readable text. And it's going to compile it down to binary. So by the time it's done, you won't be able to read it anymore unless you put it through a decompiler. But it is something that will be able to do a lot of, heavy lifting. So it's going to do it very efficiently because pretty much it's in machine code at that point. So it's the base level code that the machine can understand. So that way there's nothing really standing between it and the actual hardware. So it's literally running directly on the CPU. So we've moved on to codecs. We finished up filters. And here's where we see some of the warnings come through. Just depending on how things were implemented, somebody will have to make an update to that at some point. And everything is in alphabetical order, just in the way that it actually runs. So you can see which ones are probably the more complex coding, or in terms of the more complex thing to compile, based on how long it actually sits on a particular line. But it's actually moving through very quickly. So while it's doing this, if I open up a resource task manager just to see what resources it's using, we see the CPU is running at almost 100%. If we sort, we see that the compiler is running 4 threads, and they're taking up as much resources as pretty much they can. GPU is not really doing anything, but generally this is a CPU-intensive task, not a GPU-intensive task. And there's no way to do acceleration unless there's something that's specifically coded for it to run on GPU somehow. But it's moving along, so now we're moving into another section, which I believe we are in formats, and you can't hear it, but the fan on the Raspberry Pi is actually spinning up ridiculously fast now. It's pretty much at the maximum speed, and I'm sure it's putting off quite a bit of heat. The case that I have for it is the official case, so it's plastic, so hopefully it's not going to melt. But you know what? If it can't handle that, I think there's a problem with the case. So it's up to F, G. Again, these are more codecs. And we know it's codecs because it says libav codec. Again, more warnings. And I'm just going to leave this long form. It's something I'll put I'll try and put some bookmarks, things like that, or chapters, so that way you can kind of skip to the end of this. But I'm still going to leave it long form just so you can kind of see the whole process in real time. If you've ever tried to compile FFmpeg on any of the other Raspberry Pis, you know it actually takes forever. I know on the Raspberry Pi 2 and Raspberry Pi 1, it took them about 6 hours. So it was significant. And the Raspberry Pi 3 was the first one that could do it in like an hour. And the Raspberry Pi 4 got a little bit better, where it could do it in about 45 minutes or so, 30 to 45 minutes. And my hope is that this can do it in about 10 to 15 minutes. So let's see how that does. Although it's difficult to sit here for that long. And hopefully the new monitoring angle. You know, I'm still trying out everything with the setup that I have here. Trying to refine it and make it so it's a lot easier and less overhead to try and do these streams. Because then I'll be able to do it more often. So, just trying things out, and this is the first time I actually integrated a KVM switch. And one of the things I did is I took a Raspberry Pi Pico and went through it and hooked up some GPIO pins to what was a remote control for the KVM. So the KVM wasn't very expensive from Amazon, just kind of arbitrary, but it had a separate HDMI and a separate USB, which was perfect for the Raspberry Pi since it's got the micro USB. Some of them have mini micro HDMI on the Raspberry Pi 5 and the Raspberry Pi 4, full-size HDMI on Raspberry Pi 3, 2, and 1, and then Pi 0 has the mini HDMI. So because of that, I wanted it to be interoperable with everything. So it's certainly something where the KVM itself, I could have just pressed buttons, but that was too easy. So what I did is I actually took the Pi Pico, built a web interface onto it, and then from there made it so it would do the contact closure, or actually it just pulls a pin to ground, and that would change the input, and then ran that to a Stream Deck, which I used for changing the shots, everything else like that, and that actually changes the title. So the Raspberry Pi OS title will change based on what machine I have selected automatically when I choose the new input. So it was the cheapest way I could think of to do it, because I was looking at other KVM solutions, and if you look at IP KVM solutions, they're really expensive. So we're getting to the end of the compilation now. So we see it did the documentation. We see now it's doing the actual base programs. So we see the LD, FFmpeg, FFplay, and FFprobe, which are the 3 applications that we're actually compiling. And it did the strip command, and then we see it took 1,465 seconds on the user side, 58 seconds on the system side, and a total of 7 minutes, 23 seconds, 0.23 elapsed. And it was able to use average using 343%. So 100% is the full amount of 1 core, but 343% means that it was using 3.5 cores pretty much while it was running. So some very, very good, very good, a very good time savings in terms of what it was over previous generations. So now we can actually start using it. So we see our CPU usage has gone down, and pretty much what we can do now is do #-r. Doesn't really do anything, it just... We actually ls in here. It just pretty much finishes everything up. So we see the FFmpeg executable located in this directory. Right, so if we do /FFmpeg, which will make sure that we're running it from this directory, it should give us the default, and it does. So it tells us what version it is, it tells us what our configuration options were, which we see everything that we put in here, and it's a hyper-fast audio and video encoder. Excellent. So now we've made it, we've successfully ran it for the first time. It didn't do a lot, but it did run, and it didn't error out. So let's come up with something that we can do really quick. So let's see if we can actually put something out to the screen. So let's look up generating a test pattern. Right, and if we wanted to, we're going to do make install as well, right? So we just did make. So let's do make install. This is going to put it in the final path. Let's just finish this up. But we could test it first if we wanted to, but we don't have to. So we'll do make install. It's going to put everything where it needs to be. And then it will pretty much be permanently integrated as part of the operating system. Which is fine, unless it doesn't work. If there's a bug, because this is a snapshot, it may be something where they haven't detected the bug yet. So it's actually good practice if you do encounter a bug on the snapshot and you just compiled it. Make sure you're on the current snapshot, but then report it to them and let them know. So we did make install, now let's do #r, sorry. Went a little bit out of order, I almost skipped it. And then we're done. So now let's look for some options. So let's do generate a test signal. So we'll do FFmpeg test. We'll do generator. So we'll generate bars and tone. And it looks like somebody created a gist for this. And pretty much what a gist is, it's part of a script. But you can use it to kind of make everything easier. And even has a way to do custom messages, things like that, which is excellent. So we can give that a shot. And even tells you how to stream it out. So the guy really went to Nick Ferrando. Apparently went to the nines here and really knocked it out of the park. But we're not going to stream it. We're just going to display it to the frame buffer. And I'll show you how to do that. So right here, he wants to do frequency 1000. I don't want to do that. So let's CD again. And let's just try running FFmpeg. And it says command not found. So let's cd back into FFmpeg sources. It's not in there. Let's just ls this directory because it was based on where we specified it. And we do see FFmpeg build in here. And also a bin folder. Let's cd into bin. And there we have it. So what we need to do is we need to actually add this to the directory, or to the path file. So we're going to do export path equals, and pretty much the same way that we did it here, home/bin path. Right, we hit that. Now if we do echo path, we do see that reflected right here. So it's in our bin folder in home. So now if we do FFmpeg again, we do see it loads normally. So let's cd out of this. So let's go back to our home directory. So now we can go and we can create a quick shell file, a shell script. So we're going to use vi, and we're just going to do, we'll call it testbars.sh. Right, I'm going to insert. Oh, I need to install it. It's not the right version. There's two versions of VI, of Vim, as it were. And the lightweight one that usually comes with most operating systems requires all kinds of key commands in order to use, and is an absolute nightmare. And it takes up no space, so I'm not sure why they do that, but reasons. So let's do the same thing again. There we go. And we see it's slightly different. But now when I hit I, it inserts, so now I can copy and paste into here. So we go back to our gist. And let's just copy the entire command first. And pretty much it looks like server's local time. Oh, we could do time code, which is fun. I don't think we need to go to that level of complexity. That's for another time. But we could count frames and see how many frames we're actually getting. So we're going to do edit paste. Before we do that, we'll do shebang / bin bash. We could do shell, but it's going to be easier. Right, we're going to do FFmpeg-RE for real-time source, -F for our format, which is going to be libav filter, in effect, FI. So it's going to generate something, and here's where we specify in the -I for input. We're going to specify we're going to do empty bars at a rate of 30 frames per second. The size is going to be 1920 by 1080. Then we're going to do a second input, -F lav fi. Then we're going to do -I, and we're going to do a sine wave. And instead of doing 1 kilohertz, because if you're not used to it, you will hate it. So we're just going to do 440, which is much more palatable to the ear. And then we're just going to do a sample rate of 48K. Here's the text that we're going to draw. So it's going to do a video filter, and we're going to do draw text. And here we're going to put a message. And we're just going to say, FFmpeg is cool. Okay, and what it is, we got local time here as well. Going to be 30 frames per second. It's going to center it. So it's going to be width minus the text width divided by 2. So pretty much it's going to center the text. Then it's going to do the same thing vertically. So height minus the actual line height divided by 2. So that way it can center it, because it's actually measuring from the upper left-hand corner of the text, or left, depending on... Actually, no, it is left. So I have my screen reversed, just so you know. And then the font size is going to be 48. Font color is going to be white. It's going to have a box. And what it means by box is it's going to put the text in a box. And it's going to make the background black. And this is actually a pretty common test signal that is used in broadcast and things like that. And everything after this, we don't necessarily like. So, we actually want to create an output. And actually, we're going to delete this. What I want to do is I actually want to output it to the FB dev. So we're going to do -f FB dev. And it's going to be /dev /FB0. So that's where we're going to output it. Now we don't have a place to output the audio, and it may complain about that, but I have to look up a reference for that as well. And actually, we have to actually specify a BGRA, which is what we need in order to output to the frame buffer. So we're going to do -pix_FMT BGRA. And that should get us in an appropriate format. And just so we can just do video right now, we're going to do -AN, which will say no audio. We will write that out. And now let's try and run it. So we're going to do chmod +X test bars. And then we're going to do /test bars. We don't have draw text, but that's okay. If we actually wanted to compile it with draw text, we would have had to have specified that. But we'll just go through. Let's comment out this line. And let's just leave it at that. Let's see what we got. And let me look up a reference. So this is your friend, which is the Linux the FFmpeg documentation. So I typed in just a general search, and then I'm going to do find in here, and I'm going to do pix_FMT. We see there's 14 options. We can look at Pix formats. Right, so we did specify that right, but we need to put a correct format. So if we do, if we actually look over here and we do FFmpeg-pix_formats, it will tell us all of the ones that we have available to us. Now if we scroll up here, we have BGR0, which is not what we want. And there's just a lot of options, but there is BGRA. So let's go back over here. And it doesn't have anything special here, so there's no reason why it shouldn't work. But maybe something got messed up in the file. Oh, and I think I know what happened. So let's delete this line up here, because it actually escaped it, but then we have a comment, so it didn't actually wrap around. So I'm going to do escape, I'm going to hit D twice, and now it should be fine. We'll write that out. Let's try it again. Okay, so PIX format BGRA is not supported. We need to use RGB 5651E. Very intuitive. So we're going to put that instead. And pretty much that just comes down to what the frame buffer and the graphics card wants to see natively. Okay. So now we gave it what it wants. Let's see if it'll work. Oops. So it says no accelerated color conversion, but it is doing a full frame, 31 frames per second, which since we asked it for 30, is actually very good. It's usually very difficult to get full frame rate, but granted, we're not doing too much in terms of overlaying any text or anything else like that. But we do see that it is in fact running. Now, ideally, I would like to be able to see it. Let's see what we're actually currently using. So let's just do ls/dev/FB star. And we do see FB0 is our option, but I will say this, our operating system is actually overwriting it. So as it's publishing it, or as it's pushing it to the screen, the operating system is going ahead and overwriting it. So, which is fine. If we had a, for example, if we were doing this on Alpine Linux, and we did the same exact thing, we would see it actually output to the screen because it wouldn't get overwritten. So. Alright, so let's try something similar. So let's do a YUV. So we'll do YUV 420p. And then we can do H.264 and actually make it a stream and pull it up in FFmpeg. And we'll do -C:\v lib x264, which is CPU encoding. It's not accelerated. And then we're going to do -C:\a AAC. We'll do B:\v, and we'll do 5000K. We'll do -B:\a 128K. And then we will do, what else? Profile V baseline. And it just wrapped around, it wrapped the text, it's not a new line. And then, let's see, we'll do -preset, ultra fast. That's just going to keep the processing time down, but potentially at the expense of quality. If we did slow, for example, it would take longer inside of the CPU because it would try and find, it would work harder to find more accurate compression for a particular frame. Then we'll do -tune, 0 latency. CRF is constant rate factor. We can do 28, but we're already choosing to do 5K. So we're going to leave it at that. We're going to do -G60, which will do a, pretty much every 2 seconds, it will do a GOP frame, which is a full redraw of the screen. And then we're going to do -F. We'll do MPEG TS. And then our output is going to be UDP://127.0.0.1:10,000. And we're just going to send it into the world so that way we could pull up VLC and we should be able to receive it. Will it escape? We will try running it again. It should just start running. There it goes. I'll make it bigger again so we can see it. Actually, I'm going to clear the screen and then run it, just so we can see it in all its glory. And now let's get open the actual VLC media player. Again, this is still on Linux, just to the same machine. We're going to do UDP://127.001:10,000, and we're going to do an @ symbol, which should hopefully make it connect. We'll find out. There it is. Another option is we could have just done the @ symbol. And I do want to see if we got the tone coming through. We currently don't, but I think I might have still left the AN on there. If that's the case, we may need to remove that. Right, but we see our bars. They're being generated. And just to confirm it, if we go here and we hit Control-C, we will see our stream will end. So we see it's no longer incrementing, and it's just kind of frozen in place. So let's go back to VI. Let's see if we have the AN there unnecessarily. Right, so we see it is streaming. We see currently it's not incrementing, so we're going to hit stop and play again. See if we can pick it back up. And there we go. So it's picking it back up. Let's see. I don't know that we have any audio coming through. Oh, do I have the right audio output selected? There it is. So it was there, it was just low. Right, so we see it is working. So I can stop it. We see it stops. I can play it again. We see it comes back. For our own sanity, I'm just going to mute it here really quick, just so we don't have to listen to it. And we'll just bring this over here and we can look at a few things. We're going to go to codec information. We see it's H.264, which is what we selected. We see it's 1920 by 1080. We see the encoding, 4:2:0. We see Rec 709, which is ITU BT 709. And then we see our audio, 48 kilobits per second, 32-bit samples. And then that's it. We can go to our statistics. We do see it successfully coming in. So it's working. So we compiled our own FFmpeg instance from source, and we were able to make it work with being able to create this video. So, or create the video of the SMPTE bars. So, you know, I think it's definitely something that opens up a lot of options. If we wanted to, we could go back and compile it. We could add in the draw text flag in order to be able to draw the text over the bars. And I think with the higher processing speed of the Raspberry Pi, both for encoding as well as being able to compile so quickly, it makes for a great development environment for Linux that opens a lot of doors, and, you know, without a heavy lift and with a lot of support. So thanks for watching the video today. If you liked the video, be sure to hit that like button and leave a comment down below. If you know a friend who would like this kind of content, be sure to share it with them. I would appreciate it, and I hope they would appreciate it too. And if you haven't subscribed, please subscribe. It helps me out a lot. And then also hit that notification bell. That way you know the next time we're getting extended. So until then, take care.